welcome to the show. Hands from the couch. I think this is our first episode of 2022, so happy new year to everyone, because at least I haven't been on the show yet. I'm already blurry. That's super exciting. Come on, camera, focus on me. There it is. So I'm excited for this show. We were planning this one last year and got rolled into January for CubeCost. And CubeCost, if you're running Kubernetes, is a great way to figure out what you're spending money on, what workloads are doing, maybe where you can save some money, some better efficiencies, all that sort of stuff. So I'm really excited to have Michael and Ajay on the show today. Say hello, Michael. Tell us what you do.
Hey, I'm Michael Dresser. I'm a software engineer at CubeCost. Do lots of backend work, open source work. Used to do some open source contribution to Kubernetes, and now I'm here.
Hey, I'm Ajay. I'm one of the original authors of the project, as well as co-founder and CTO of the parent company Stackwatch.
So Ajay, as a co-founder of this project, you probably have the best elevator pitch of anyone. So go ahead and tell us what is CubeCost? Why would I want to install it? What can it do for me?
Yeah, so CubeCost does cost management and capacity planning for teams running Kubernetes. I think you'll start to see as just the number of services grow, the number of your team members grow. I mean, depending on where you are in your Kubernetes journey, maybe you're already having this problem. It's just difficult to see who's spending what, where, and why. And those are the, and then once you know that, how do I reduce that spend without impacting performance? So that's kind of the overarching problem. We help Kubernetes and cloud native users in general track, optimize, all that kind of stuff.
And I didn't even ask this before the show. Like, what does the parent company do? Are there other tooling and other things that you're doing as a parent company? Like, why is CubeCost part of a parent company?
Yeah, I think the mission of the parent company is sort of to make all to optimize all cloud native software. So there's stuff beyond Kubernetes that early days still, but stuff like ECS. I mean, Fargate is kind of Kubernetes, kind of not. We can get into that a little bit more later, but things beyond Kubernetes, like just cloud native optimization, is the mission of the parent company. Although CubeCost is our focus today.
All right, and that makes sense. Like the tool, like when I would use it, because when I started as a sysadmin, like I bought servers and like I knew the cost of that server up front, and right, like that was a long-term cost. I'm like, this is on the bill for this fiscal year, and I'm going to use that server for 4 years. So I just divide that cost before, and it didn't matter if I used it or not. It didn't matter if if it was 100% CPU all the time or 0.5% of CPU all the time. It was still like a box that I had that I allocated to myself because I thought I was going to use it for some reason. And now in like
and my guess is it was closer to 0.5% of CPU the whole time than 100%. And Kubernetes lets you split up that VM into constituent parts, and cost savings was a big motivation for people to move from just VMs to containers to a same system for scheduling and networking between those containers. But then the flip side of that question becomes, okay, like how much did we save? So very much like day two for enterprises is going to be, okay, like we spent all this money doing a migration from VMs to Kubernetes. What did we accomplish, and how do we make it better? And yeah, right. Go ahead. Yeah.
If you didn't measure it, it didn't happen. Right? Like that's just like it. You got to have a number on it, and you got to show some progress. If you say like it was cheaper, finance is going to say how much, and they're going to say, how do you know what is the goal here? And so like that's really
just like spiking out the project and saying, look, like moving these VMs saves this much, so give me 5 more DevOps engineers to manage the transition from Kubernetes from VMs to Kubernetes is where that's I think where we were meeting people in their journey 2.5 years ago. I think now it's more like the day two operations of like running and optimizing, but that's kind of like the story of the project and the company behind it.
Mm-hmm. Yeah, it makes sense. And tell us a little bit about CubeCost specifically. I know it's open core, so there's some pieces that aren't open source. There's some pieces that are open source. I know there's also an offering for hosted software. Can you divide some of those pieces in here? If I'm an open source user, I have my own Kubernetes cluster. What can I run? What value do I get? And where do I need to actually shift that over to, like, I need to pay you money or have a contract?
Yeah. So a couple of let's take it through like the 3 steps through this journey, right? Like let's say you're installing the open core. The open core, what's generally open core, what we think of as open core and important to be open core forever is kind of like the fairness attribute, right? If we're doing like chargeback, you want to know what the model of how we're doing billing for constituent services, what that looks like, and the math behind it, right? So that there's nothing opaque there, right? And there's a reference implementation of our spec that is totally open source. You can just go grab a container and get it runs against either you can install a Prometheus with the options that we have in our Helm chart, or against whatever PromQL endpoint that you guys are using. You take that open core project, you take our open core project, hook it up to a PromQL endpoint, and we run raw PromQL queries against that to break down costs into constituent containers. So that's and do that fairly, right? So that's the open core. Beyond that, like you're going to want historical data, retention, the ability to slice and dice and join that with cloud assets, things in your cloud provider. That is all free in our community edition. Not all that code is open source, although we are like moving in the direction of open sourcing more there. And then hosted, etc. Stuff like that is where you pay us, or very large installations of our community edition. We call that enterprise, and that's help supporting that is where you pay us as well.
Got it. And so that makes sense. Like I have Kubernetes, I'm running workloads, but like CPU and memory is not the whole story, right? Like I have load balancers, I have EBS volumes, I have other things that are related to this workload, and KubeCost is helping me collect all that information, whether it's a internal Prometheus endpoint that you're collecting some of that data, or external. So I'm assuming you also are scraping the cloud APIs for me to say like, oh, how much is it? Which instance type do I have? What load balancer do you have? How much does that cost based on my account itself to like actually collect that?
And getting to penny accuracy is, it requires a little bit more, right? It's going to require integration with your actual AWS bill, for example, like a VM, spot VMs especially, come up. They exist in the world for an amount of time before they join the cluster, before any of our open core software can track it. So in Community Edition Plus, what we do is we take that bill from Amazon, go back, split it up accurately among all the constituent containers, and like just do that joining, but a little beyond the scope of the open source open core project, where we do our best with estimations.
Right.
We do estimation if you provide the open core project your key, like we do our best with estimation, but it's infeasible and beyond the scope to do like penny accuracy with the exact bill. I think yeah, maybe this will make more sense if we jump into a demo.
Right. Yeah. And that's like I wanted to get to, because anyone that's tried to give your boss like, this is what my thing cost, is actually very difficult if cost is variable and I'm in different regions, or I'm using Spot, or I'm using something else. Like all of those variables add up to be just like, wow, this is actually kind of hard. And so the value of KubeCost, just like it's doing that for me, does so much stuff. So I do want to, let's jump in and show off. I want to link to the install docs too, but let's pull in Michael's screen here. I know we're going to walk through an install real quick, right?
Yes, we are going to walk through an install real quick. So as you can see, super fresh cluster here, just so I can show you really how easy it is to install KubeCost. I've got this install command right here. It is create a namespace, add a Helm repo, run Helm install. It is really that simple. It'll get going in a second. And while we let that happen, we can just swap over to a more useful cluster. I can show you just really quickly a CLI we have for kubectl. So we have kubectl cost. We have like a nice namespace command. Here we go. This is truly will get you up and running in the CLI pretty quickly. If we hop back to that demo cluster, which we can do at the end, you'll see the KubeCost is up and running in just a couple of minutes. I think Justin can just share the install instructions. It really is just Helm install, and you're going to get pretty much everything I'm going to be showing off in the actual UI. And then, of course, kubectl cost can come from crew, if you know what that is. which is a pretty awesome package manager for kubectl plugins. Yeah. So with that out of the way, yeah, go ahead.
So go back to the screen share there on the
yes,
on the CLI. I just wanted to make sure that I understood all the tables there. So let's pull it back in. So there's a 7-day window. So in the last 7 days, and this is by namespace, right? So your Sean namespace, your Austin namespace, your total cost over 7 days is showing $92 total, right?
That is correct. Yes.
For all that. And then what's this cost efficiency? Like, why is that on this like primary output for this table?
Yeah, we like to show this fairly prominently because it's very often the case that people are wasting a ton of their resources in their cluster. And I think we'll talk about that like pretty in depth when we talk about savings and CubeCost. But the high level is a lot of people over request resources for their containers. And so they end up with all this capacity that's getting allocated by Kubernetes and never being used. And cost efficiency is a rough score of how badly you're doing there. Or how well.
And I'm assuming the goal is 1, right? Like the CubeCost agent is a 1. Like that's like, I'm assuming that's the best you can do.
This is an ideal place to be. Yes, it's a 0 to 1 inclusive.
I think we can get into more on efficiency when we look at the product. I don't know if you want 1. Now, you like things like headroom. Maybe you can go like quote over 1 if you allow CPU throttling. Like some services that aren't latency sensitive, it's okay if they get CPU throttled if you save a little money, and some of those trade-offs will become a little bit more obvious as we like go into the UI and the savings and what you get beyond kind of like.
Yeah, it very much depends on how you profile your workloads, right? Like if you have a perfectly predictable, totally stable workload, I think 1 is a good target. I think a lot of people, you might have bursty RAM or something like that you may not be fully aware of. And so maybe you want something like that's slightly over requesting on your RAM just in case.
I feel like on this show we should have like a buzzer or something whenever someone says the D word. Depends, because it's like it's the magical like. Well, this is actually because like you're like if you have a perfectly predictable, stable system, like maybe don't run it in Kubernetes as well, right? Like because I could buy a server and I could just stick it on there and I never scale it. Like that is also the other option. But in this case, like we're getting that efficiency through this mixed cluster, through all these workloads coming and going, and really Kubernetes and containers shine when they're scaling up and down and they're doing more dynamic stuff, which is, again, it's like meeting 1, like maybe not, but over 7 days, your requests and usage of the CubeCost agent was very accurate for that 7-day window.
Yeah, it's a good thing to pay attention to. We can talk later a little bit about how users of CubeCost can set alerts, like if you have teams use, they get 1 namespace, or products get 1 namespace, or teams get a label or something like that. You can automatically alert if their efficiency dips below like a given threshold. And that can be a pretty good indicator of people are doing something wrong and you should check it out.
Yeah. Also, there's a comment someone can't see. I think that might be a LinkedIn thing. I see you're coming from LinkedIn. If you watch this on Twitch, twitch.tv/AWS or youtube.com/containers from the couch. I've only streamed one other show to Twitch, so I don't know if there's a problem on that platform. So if you're having a problem seeing it right now, go ahead and check it out on one of those other areas. So let's actually go to the web interface because I have a simple UI here that I can see in the terminal. I might be a little interested, but like I'm assuming I can't do a lot of things from the CLI.
Yeah, this is missing a lot of stuff, but I just as the author of the thing, I will totally pitch it and say there's a lot more we can get here. It might get a little overwhelming for this small terminal window. So we can get a breakdown of like cost by resource like CPU or RAM. We can get 30-day windows. We can get cost of your assets like your nodes and things like that. But I think that we can show that a lot better once we hop into the
and Michael, you said you're the author of the cost plugin, right? You're the original author for CubeCost. Okay. And so yeah, there's a bunch of stuff in the data storage here. That's all on Prometheus for those 7-day, 30-day rolling windows.
So the core data is all in a Prometheus or Prometheus-like database. If people are familiar with sort of things to build on top like Thanos, Cortex, etc. But this is just hitting the CubeCost API. So CubeCost, the product, relies on Prometheus for data, but our APIs are way faster than just running manual Prometheus queries, because it turns out when you hit 50, 100, 250,000 pods or containers in your cluster, Prometheus queries break down pretty fast.
Yeah, that's a lot of data.
It is.
So go ahead and let's jump into the actual web interface, show off kind of what else we can do and what we might want to do if we switch over.
Yeah, let's. I'm going to just switch my share here.
And if anyone else in chats has questions, go ahead and leave it in the chat. We'll answer it here on the show. If something you want to see, just let us know. Add that screen share back in. There we go.
Cool. So just really quickly, everything I'm going to show you today, like you can totally use, just run that Helm install, it'll get going. Obviously, you need to gather data, so I can't just look into the past for free. So I'm going to start here on basically the analog of the kubectl cost command I just showed you. We call this the cost allocation page. This is going to show you the cost of any given Kubernetes sort of concept over a defined window with all sorts of filters and things like that. Right now, I'm looking at it over the last week, the last 7 days by namespace. This is exactly analogous to the kubectl command we were just looking at. But of course, we have all sorts of other things you can aggregate by. Namespace is super common. Label is super common because those are really common ways of how people sort of break down their workloads. And so we can see we've got the same namespaces we're looking at in that command. We've broken their costs down a little further, so we have CPU, GPU, RAM, PV cost, network, and load balancer. These are all sort of in cluster costs. These are costs of Kubernetes stuff. And then sort of externally, and we can come back to this in a moment, we have shared cost and external cost. That same efficiency thing from before, and then a total cost for every namespace here. Again, like the kubectl cost command. Let's dig in a little further, and we'll talk about sort of how we calculate these numbers. So we can click into the CubeCost namespace. Now we're looking at it by what we call controller, and I think a lot of Kubernetes documentation doesn't always standardize, but I think controller is a pretty good name for this. These are things like deployments, daemon sets, stateful sets, all that jazz.
Those are the different types, the different resource types in the.
Exactly. Yes. Okay. Usually the things that are managing a group of pods is sort of what we would call a controller. So we can check out, again, all the same data, just broken down even further. We'll hop into the main CubeCost deployment. Now we have it by pod, and we go one further, and we can look at it by container. And we can look really exactly at how CubeCost is calculating our cost. So over the last 7 days, this specific pod has been running for about 101 hours. And then we've broken down the cost by CPU, RAM, PV, and load balancer. So it's important to understand sort of the three components of cost that we think about at CubeCost, and we think most people should be thinking about. We write a lot of documentation about why this is right. We look at how long something was running. We look at how much of a resource it was allocated during that time, and then the underlying cost of the resource it is using.
And Michael, just allocated meaning the maximum of the requests and usage. If you haven't set a request, that's roughly what the scheduling algorithm uses, although this is a little bit simplified, but just to be clear on the definition.
Yeah, so basically the idea of an allocated resource is the process that's running on a container may be using a certain amount of RAM, and then the request of RAM you set in like the container spec might be much higher than that. For Kubernetes, for all of its intents and purposes, the amount of RAM the container is responsible for, and therefore the pod is responsible for, is the maximum of the usage and request, because it won't schedule something on top of already allocated resources, already requested resources specifically. So even if you're not using much, you're still responsible for, you've been allocated a certain amount of a resource. So it's
and a lot of times with workloads, like that's a strategy to keep my own availability, my own uptime, to avoid noisy neighbors. Like people do that for a lot of reasons.
Oh yeah, it's a huge thing. I mean, I've heard it's been considered best practices ever since I started using Kubernetes like 3 years ago. I hope people are doing it. I'm sure plenty of people are still getting their workloads killed because they're out of memory and trying to allocate.
Right.
In practice in the industry, sometimes people do, and sometimes people don't, and sometimes people don't because they don't know, and sometimes people don't because they have a specific strategy where they want their resource to get evicted to save money, right? Like you get billed on, at least our users using CubeCost get billed on their the max of the two. So they intentionally drop the requests because evicting is fine, or like don't set a request because the workload is low priority, and evicting is fine. I mean, you're going to hit the depends buzzer again, but it depends. And I think these are interesting things to think through there. Yeah.
And real quick, I saw Eve has a couple questions in the chat where one is like, do you need to run this in the Kubernetes cluster? Like, ideally, yes. The instructions are, here's the Helm chart. Can you run CubeCost from outside the cluster as well?
So yeah, we actually you can. Here are sort of the caveats. We do need an agent in all of the clusters to collect all the information we need. This specifically this allocation stat we compress into, we could do max usage and requests from Prometheus, but that kind of thing can be a little bit expensive. So we do emit data as agents. So our the agents, which are actually, you can just run the open core agent in your clusters. But outside of that, there's a couple of things where you'll have to disable essentially are like, the primary CubeCost is both an agent and a metrics reader. So you'll have to go through some steps to disable it as an agent or running in agent mode to do that. But we do have users who run essentially, well, this particular user I'm thinking of does run it in a Kubernetes cluster, but they run it like walled off entirely, so it doesn't need any of the permissions and is purely just a consumer of a PromQL endpoint. So that's possible. We don't today offer like great support for that in the open core. That's generally for our enterprise users, but it's something we can look to do in the future. It is possible with all the flags. It's just not fully supported, if that makes sense.
And that Eve's second question here is like, just needing Prometheus query data. With some of these other resources that you're getting, the physical volumes, the load balancers, like we also need to call the cloud provider APIs too. So it's like, depending on where you're running, you have to have those permissions, IAM or whatnot mounted as well, right?
Well, so for things within the cluster, we try our very best. If there's a mapping that exists between the cloud and what's within the cluster, I think the main thing is like the agent has to emit certain things. We depend, and there's architecture diagrams that we could get into, or like we can at least share links for. But we do need some. We do need things like deployment. Like there's certain things like kubestate metrics, which is one of our dependencies, does not emit or will not emit by default. And we need those, and our agent generally emits those. Things like the selector labels for services, for example, is one that immediately comes to mind. I think that's not by default emitted in kubestate metrics or in the OpenStack, in the standard telemetry stack of kubestate metrics, node exporter, and the cAdvisor metrics. It's emitted by our open agent. And then you don't need cloud permissions to enumerate those resources, but we do get a lot more accurate and that kind of thing when you add those permissions.
Right. And last question from Eve, like, which I'm sure we'll get to, is how do we see the over provision resource costs of like, hey, I wanted, my workload said it wants 10 CPU to run an Nginx pod. Like, that's probably not something that we want to do, but like, yeah, I'm sure you're going to show that as well.
Totally. Yes. Yeah, we'll get there in just a minute. Let's just finish up here really quick. So, time running comes from Prometheus, of course. Resource amount is also going to come from Prometheus with that max formula we talked about. And then your hourly rate is going to come from a few different places. This is, if you don't do any integration like Ajay was talking about, this is just going to be, we'll talk with whoever your cloud provider is. We'll hit their API. We'll find out, we'll match price with region with node type and break that cost down by resource. If you set up the integration, we'll actually talk with your cloud provider's billing report. In AWS, that's your cost and usage report, I believe is the CUR. And that'll get a lot more accurate with the things like the adjustment, so we can get an exact cost for you. And even if you're running on-prem, you can supply custom pricing. Like if you have bought machines or rented machines, you can put a cost in there too.
And this is another thing where we, that is open source, but we work closely with, if you're an enterprise and you've bought, a bunch of Dell machines or whatever, there's a like depreciation spec that you can that we can help you to like get accurate on these on the supplied costs.
Yeah, so this isn't just, this is, you can run this on-prem with some of those numbers and be able to do the math still.
Yes, exactly. You can, I think it's core to us that this runs wherever Kubernetes runs. And some places Kubernetes doesn't run, to Eve's point.
Indeed. All right. So lastly, but not least, on this page, we're going to talk about, just briefly, we have like these things called save reports. So let's say business team, finance team, engineering team needs a specific view that they know all the parameters for, and you need to produce a report for them. You can save a report. You can then download it as a CSV. You can download it from the API so that you can sort of programmatically access things and also put them in a format that other teams might find a lot more useful from this view. And we've seen a lot of integrations that our users do with their BI tools or other things where they talk to our API to sort of hook things into dashboards that other teams in the company actually like to use. And so all the data you're seeing here, we have documentation of our APIs that build these views. So you can sort of replicate this in queries if you like.
Right. My finance team's going to want this in Tableau or something else.
Exactly. That's the kind of thing that they'll totally be able to do, and we can also provide sort of enterprise level support if you want some extra heft behind that integration. But I don't think it's too hard.
Something near the beginning of this, when you were showing the groupings, I saw clusters, which is great for like, can I either define some of these? I see environment too. I'm trying to see like, can I see how much my test environment costs or how much my dev environment costs based on either an arbitrary grouping of tags or cluster level, like this AWS account is dev. So just how much is the clusters cost in that dev environment?
So I will say there's actually an open GitHub issue for your last point, which is how do you do it how do you map accounts to concepts? These are Kubernetes labels to start, but or like cluster level groupings. But I'll let Michael take it over. That's just the big.
Yeah. So maybe you have like so multi-cluster is a paid feature of the product. I will set that up first because it's a little more complex. But what you can do is you could maybe say I want to aggregate by cluster. I think we have 1 or 2 or 3 clusters set up here. And then let's say like all of your test environments or all of your like your test deployments are set with some label. You can filter that here by like, that's the wrong button. You can filter here by like app is, I don't know, test or something like that and add this filter. I have nothing labeled app test. But yeah, you can sort of set up any sort of level of aggregation or even a multi-aggregation plus filtering and all sorts of parameters, one of which we'll come back to in a moment when we talk about over-provisioning.
And that makes sense for like, I'm not going to get that in the CLI, right? Like my kube control commands are going to one cluster. I'm seeing one sort of view of that. Here, the product is showing me more of a holistic view of everything that's going on.
Yeah, so interestingly, kubectl cost does talk to the exact same API this page uses. So you don't get all of these flags, but you do get like actually a fair number of them. So we could replicate to a certain level what I was just talking about. But if you get too complex, you may have to switch over to the UI or write your own queries or just make an open source contribution to kubectl cost to get what you want.
Yeah, I think that's a good architectural point though to loop back in. If you've got a like a PromQL endpoint with multiple clusters, like this will display multiple clusters. This is not like it's joining a bunch of data. The agents emit data to that PromQL endpoint, and then this gets joined up by our essentially by our APIs. That multi-cluster data plus cloud data plus a variety of other like potential sources, including like those like a pricing sheet that you can supply. So that's what's going on when we have that like multi-cluster view.
And my last question that came up from this is, can I actually see how much cost is from my non-workloads? If I see daemon sets, I think things that are like running, like I would love to be able to see either how much are all my sidecars costing, like what is my Istio cost across the cluster, or how much is that agent that's installed on the OS that's not a container, not a Kubernetes deployment, but how much is the OS layer of my nodes actually costing me? Those are two things that are typically left out on a lot of these things, being able to easily see some of that. I don't know if that's possible, but that was two questions that I just had of like, I would love to be able to see like, oh, look, all of our nodes are costing 2% of these clusters, or this is some level that's not containerized.
So a certain amount of that is possible in terms of, if you want to like figure out how much your sidecars are costing, I can't know which of your containers are like specifically the ones you're talking about. You can filter some things by like label if you have that. The OS level stuff, like how much is kubelet costing me? I don't know. I don't think we can answer that question. I'm not sure what the metrics might
Well,
be. Do they exist?
it's grouped under idle today.
Yeah, so we'll get there in a sec.
Okay.
Yeah, we'll get like, let's put a pin in that. You can see that in aggregate. I think you're asking for something slightly different than the idle resources, in that you're asking for the unallocatable resources. I think we do have that data. It's not on this page. It's the system resources that node exporter exports to like generally answer the question. And then but not all versions of node exporter, and not all like, so we're gonna hit that depends bell again. But the answer is like yes, and we can help you find the metrics to do that, even if they're not necessarily like in this in the application today. And to circle back on the all your sidecars, you can look at the it's the like unallocated line item. Like we'll give you some idea. If you go to the aggregate by controller and then look at the unallocated,
I might have that hidden right now.
Everything. Yeah, we might.
Or I might have nothing unallocated because I have no workloads like that right now.
I think Eve also says cross-plane or AWS ACK integrations. We'll get to that in a little bit under the assets view as well, and how we.
Yeah, that is a great segue into what we're talking about next. So what we've been talking about sort of here in this cost allocation page is just cost on Kubernetes specific resources. So we're all talking about Kubernetes concepts, right? We're talking about namespaces, we're talking about controllers, we're talking about pods, all that jazz. What we're not talking about is actually how much do your nodes cost, and sort of as an extension of that, how much just things you're paying your cloud provider for are costing you. So if you don't set up your integration, you're mostly just going to see node costs on this asset page, but this cluster does have an integration set up with AWS. So we're pulling in all of our out of cluster costs. So here we see, EC2, we see Athena, we see our EKS costs, S3 costs, etc. So this is just a nice like high level view. Like this isn't our main thing, but it's a great sort of high level view to direct people towards. And we can break it down a little bit in like EC2 by like which are instances, some tags, and some cost data about them. The real key here though is, we've got these out of cluster resources. A lot of the time, you'll have your in cluster resources like a pod talking with an S3 bucket that's maybe dedicated to it. So we also support tagging your out of cluster resources such that they get picked up inside CubeCost. And if we go back to this cost allocation page, there's this external column right here. And that external column is actually going to be pulling in that data from the cost and usage report in AWS's case, finding the tag, linking it up with, in this case, the CubeCost namespace, and making sure our costs sort of line up. Since we're also now talking about the actual underlying compute, the thing that's really on our bill, we can talk now about something called idle. So I'm just flipping idle costs from hide to separate. You'll notice that we've just switched to a different view here on cost allocation. This is every day, and then each little row of these bars is one namespace. So now this pretty big set of gray bars has appeared. This represents our idle cost. A way of thinking about this is we went back to our max, our allocated resources. This is our max of usage and request. But of course, if you're over provisioned, you have some excess of resources, and we can put a price on the excess resources that exist in the cluster. So maybe you have 40 CPU cores free and 90 gigabytes of RAM free. There's a cost to that. And when you bring in this idle cost concept with the cost of the Kubernetes stuff, then you can match the cost of every day, including idle, to the cost of the actual like daily report you see on your bill. because we're fully allocating all of the cost.
And this is breaking down per day, not per node on idle costs in this view.
This is
So
per cluster, but actually we can do it by node too if you want. You can just go to idle by node. It's if you go under the idle view,
Share by
just
node.
share. Yeah, so if you want your idle on a per node basis, you can do that.
Yeah, and then what this does is it shares the cost of the idle resources to the workloads that are running on the underlying node, right? Because if you don't want to just have an idle line item and you want every namespace to have a cost and all those costs to add up to the cost of the cluster, this can be useful for like billing and things like that. If you're intentionally over provisioned or not, then you would share your idle costs sort of proportionally. Or you could separate them. I think the separation is most useful when you're thinking about optimization, because this is like a huge thing to look at. You're saying, holy cow, half of my cost on January 13th was idle, was wasted.
And that's what I was curious about, because like if this is a node level, like the smaller days there, I actually want a buffer, right? Because if a node goes down, if I have a problem with something, like I want some failover, I want a buffer there. So like paying for the idleness is just like a assurance of uptime, right? In some regards, especially in Kubernetes. So like that's a good thing to some regard, but it's a bad thing if it's getting to be like 50% or something. It's like, actually, like I don't need that much failover. Like where am I actually spending this money? And there's also situations where like workloads, should have zero idleness, right? Like I came from an area where we used to render a lot, and like 100% of the CPU and 100% of the memory was ideal for us, because it's like if it just failed, like I didn't care, I just ran it again. But I wanted to consume all of the resources available for compute and memory. So it's very different depending on the type of workload, how much fault tolerance you have between nodes and between days and regions. So that's a really interesting thing to look at, as like, what does idle mean for your workloads and your business?
Justin,
Absolutely.
I think I'm gonna have to hit the depends button on you.
I actually did I make it like it depends. There you go. I made this. There we go. It's kind of like a Pee-wee's Playhouse, sort of like we need some actual like lights and stuff like that. But yeah, no, I just made it.
I think our philosophy is always like, here's like you're asking questions about, I want to split it this way versus that way. I want to see amortized costs, unblended cost, all these different ways of viewing. We just try to offer UI, at least here, UI things where you can slice and dice in different ways, kind of get costs to add up, etc.
And so a couple other questions. Bob the Lonely Turtle is asking how close this is to estimated versus actual. And I think you're mentioning there was the adjustment, right? If we're calling the API.
So I could probably spend half an hour on this. We've got some pretty detailed docs on like estimation methodologies and reconciliation methodology and all of the above. So one sort of point is your AWS services are often a superset of Kubernetes services. So let's assume to start that CubeCost Kubernetes covers 100% of your AWS services to start. Then there's 2 points. One is we are taking an estimate, and that based on savings plans, RIs, spot instances, etc. There's a period of time before Amazon publishes your like actual bill, for which we take our best estimate. We've seen those get within 10-ish%. Now, once that bill, that detailed, I won't say detailed billing report, that's a separate thing. Once the cost and usage report with like resource IDs becomes available in Amazon, we've seen that lag 6 to 48 hours, just depending on size. But at that point, once it becomes available, this should typically be within a couple of percentage points, like 1 to 2%. And I will say, though, that Amazon continues to update your bill for like a full month. And so we continue to track the cost and usage report bill as data comes in and backfill against that. So
nice.
2 sort of answers. One is without any cloud integrations, we are only as accurate as node costs on the publicly available pricing API and disk costs on the publicly available pricing API. With kind of like the open core like estimation where you add a key, about 10% seems reasonable, given that there are things that we cannot address purely from within the cluster, such as, a spot node becomes available in AWS. You start paying for that spot node, but Kubernetes doesn't register that spot node until it joins the fleet. And then, in the free community edition and enterprise plus, within 1 to 2%, because we can take your actual bill and do detailed reconciliation given the resource IDs within Kubernetes, and outside and some other facts we use querying the cloud APIs to match resources within Kubernetes to external. And I could, there's 20 more minutes on this methodology, but that's the high level.
And that kind of leads us, since you're calling these AWS APIs and looking at that allocation and bill, Carl's asking, can we see other things in here besides just external? He also asks, can you enhance this? Because it would be great to see, here's my CloudWatch logs, right? This is the percentage of CloudWatch logs. If I have one app that logs way too much, hey, that actually drives my bill in a different direction depending on other apps. And so can you see more details in this external or add other services?
Michael, I don't know what build this is running, but if you click on the ... on next to CubeCost, you can see for a column with external. I think if you go, it's possible.
No, I think I might be on an old build right now.
Yeah, this is a older one, but if you go to the assets page, you can do it by
so you can see it broken down on the assets page. Right now we only have one Prometheus thing going here, for example.
Yeah, so it is by the cost allocation tags on AWS, right? So if you add a cost allocation tag, we've got a set of standards, or you can import one if your organization's already using that. You can tag things Kubernetes namespace, and we'll pull it in here.
Cool. So if I have my CloudWatch log group with that cost allocation, you will associate that back, and I can see it here and see which workload is using which log groups.
Yeah, let me be clear here. I think this is Community Edition Plus.
Okay.
The Open Core concerns itself mainly things within the cluster.
Yeah, good distinction there. And I also want to address, had one more question just about someone studying for SA, is KubeCost something more advanced? And yes, this is more of a enterprise. You've been using Kubernetes. You want to understand how you're spending information, and KubeCost is a third-party tool that integrates at the Kubernetes layer to say hey, what am I spending money on in my cluster? So this isn't something native to AWS. This isn't something that even requires AWS, because if you're running Kubernetes on-prem or somewhere else, you can use KubeCost in these areas. So this is a good tool that if you're running Kubernetes and you want to know where am I spending my money, you get a detailed billing report that breaks down exactly where you're spending that. And at the AWS side, we're not doing that. We're not looking into your workloads because we're not running stuff inside your cluster to get these APIs at the namespace or label level. So the billing that we're going to give you at AWS is more just on the here's your cluster, and maybe here's some allocation labels or tags in the resources, but we're not cross-preferencing those to your workloads themselves. KubeCost runs with your workloads and has more access into the details of what they're doing.
Yeah, so just to drive that home, I'm on the assets page in KubeCost, which is talking with our AWS cost and usage report. And this cluster, the specific one I'm looking at right now, shows up under our Amazon EKS costs. And we see the cost of just this cluster. But of course, we see all of our AWS clusters in here. And then if we go to cost allocation, we're actually talking about the in-cluster stuff, which is exactly what Justin is talking about.
And to this point of what Bob the Lonely Turtle was saying again, 1% allocate accuracy is amazing. But what the finance department actually wants to know is projections, right? They want to know what is that going to lead to in 6 months? And I think you have some things you can show off with that as well.
Yeah. So just really quickly, we can talk about monthly rate, where we just sort of roughly project the monthly cost of a given namespace, if you like. This is, of course, relative. This is all relative to based on the cost in the last whatever window you choose, 7 days. You can talk about that. But I think a lot more interesting to talk about is savings. So, really, we've talked about these idle costs, and idle cost is a killer. And we've also mentioned that if you over allocate resources, because we've got that max of usage and request formula, if your request is extraordinarily high, you may be having problems just wasting all these resources. So we can hop over to savings and look at some ways that we can resolve this. I'm going to talk about container requests. I'm going to talk about your cluster size. and then very briefly about abandoned workloads. So container requests, as we've talked about earlier, people often over request. First of all, it's like a best practice so you don't get your workloads evicted. But also, I have been a developer on a Kubernetes team where I've over requested resources for my containers because I want to make sure they run great. And I have no idea what their performance characteristics are like in the real world. So what?
And I mean, like your time's expensive to figure that out, right? like
Oh
that's
yeah,
like
well,
it's
I
all
just
a
pick a
balance
number
of
on it.
right. It's just like, oh well, I could just like throw some extra money at this and like, oh, that didn't work, I'll scale it up more, or I could spend a week actually figuring this out. Like a week of your time is very expensive, so it's really about like how many workloads does this mean? Like what is that savings? And this is where the savings plan actually is just like, well, let's just figure it out for you of what historical usage is, because like I know plenty of Java apps that are going to spike to 3 gigs of memory at startup, but then they idle at half a gig, and it's like, well, I have to adjust for that or figure out like what do I actually need. And in this case, like you're doing some of that savings calculations for people, right?
Exactly. So of course, as we've talked about earlier, all workloads have different needs, and all clusters even have different needs, because a lot of times people run like a dev staging prod cluster. So we have different profiles that kind of support that idea, where we like rough profile all your workloads at a different levels, and then try to suggest better requests and put a savings number on how much money you can save by actually applying these requests. So
That's
like
great. That's great right there, because it's just like look at the highest number of savings. Like don't find the like 5 to 10 cent savings and spend a bunch of time on that. It's like actually maybe just look at that $50 or something. That's like, oh, it's worth the
Exactly.
time.
And we have truly helped some of our customers save millions of dollars just on this and the next view I'm going to show you, because people are over allocating all the time. And we can also actually show if you're under provisioned. So as we mentioned, like sometimes you can be under provisioned, overusing your resources, and you might be in danger of getting your workload killed if some interesting circumstances happen. But yeah, so we see savings numbers for all the things. We talk about CPU usage and requests, and then we have a recommendation. Likewise with RAM usage, your current RAM request, and then our recommended request. And we put a number on that, which on this cluster is pretty small because we've done some optimization work using our own tool. Some nice dog fooding there. And we can sort of follow that up is once you reduce your container requests, then you might want to resize your cluster. And this ties directly in with that idle we were talking about. Since we know how much of your cluster is idle, we know the rough resource usage of all of your workloads, including their peaks and averages. And we can put that through a formula and give you a recommendation, again, with the same sort of profiling thing. How much excess capacity do you want? So we'll suggest an instance type, an instance quantity, and an estimated savings of applying that recommendation. So this then takes care of excess spend within your workloads and then excess spend on the cluster itself. And that's kind of a killer combo for a lot of our users.
Yeah, and just to add on to one here, like you can also do your request right sizing and then run the cluster autoscaler or something like that. But even the cluster autoscaler won't change like your node classes, things like that. So this is kind of like static recommendations for that piece.
And how does this relate to we have Carpenter is our open source autoscaler for the cluster that isn't a node, like same node stamped over and over again. And it does try to find that sort of right sizing for workloads that are coming in or unschedulable right now for that sort of like dynamic scaling. But that's not always the case. So does this have any integration with like, what if every instance type is available to me? Or what if I want to reallocate things to like find cheaper instances? Do you have any sort of way to do that?
Yeah, this piece is all instances. Honestly, Carpenter I think is fairly new. I haven't looked at it in a bunch of detail, but just using the cluster autoscaler as like a rough analog. I think the monitoring piece is still very important, and the like understanding what your services are doing and why. So like, let's say you expected Carpenter to scale something down or change the node class or something, and it didn't, right? Like going back to that request sizing page, going back to those monthly costs, and really understanding that is kind of like where I feel like we fit with the automation tools, things like that. I think there was a question earlier also about like ML tools to do this kind of automatic optimization. I mean, we've got a number of tools. They're not ML. They're like very heuristic driven with like request sizing and like the cluster autoscaler and things like that. that basically do automation here. I think automation is a really interesting problem, but you need to always understand like why your carpenter or why your cluster autoscaler is making the decisions it is. And I think this is that like historical visibility piece. And we do see people take the request sizing API and like feed it as data. I don't know much about Carpenter, but use it to feed data to like their like Argo or their Spinnaker deployments to automatically do that right sizing. We provide the data layer in general, and then bring your own automation tool, whatever you're already using, or if you're using nothing, we've got a couple of like other open source projects that do simple automation based on our APIs.
Yeah, and that's what makes sense. Again, these recommendations are at the node group level, and Carpenter doesn't have node groups. It's just instances, and they just happen to exist. But we mentioned earlier, like a lot of the benefits here are in sort of the dynamic environments. There are things that are auto-scaling. You have horizontal pod auto-scaling, vertical pod auto-scaling, cluster auto-scaler. Those are all in the mix. And so how do you tune those things to find that optimal cost to availability to utilization, I think is really important here, where CubeCost is going to really shine for a lot of people.
Yeah, and I think the deeper everyone, and especially our users, get into their Kubernetes journeys, like you see more and more interest in this automation, as I think drove probably a lot of Carpenter development, and is driving some of our internal R&D right now to sort of answer a lot of these questions for our users.
You want to run Carpenter, like prove to yourself and your boss or whoever that Carpenter is saving us, $1 million a month, that sort of thing, or like, why isn't Carpenter saving us 10 million? Why is it only saving us 1 million? Those are the kind of questions that we want to make easy to answer. Although you will probably see, Stackwatch, the company, develop stuff for people who want to use it, or we should be playing nice with all the open source tooling in the system that people are already using to automate their cluster.
Okay. Cool. And the last saving piece I'll talk about, I think container requests and right-sizing your actual cluster nodes themselves is really important. There's other stuff we can talk about, including like recommending reserved instances and things like that. But I'll just highlight really quickly abandoned workloads. So I've found it the case, especially on smaller dev clusters, that I might make a bespoke pod at some point that's going to do like a really specific thing for me while I'm testing. And then it's like the weekend and I forget about it, and it just sits there wasting resources and wasting money, therefore. So a CubeCost can pull in actual like network transfer data, loop that in with your network costs. And what we can do with that data actually here in abandoned workloads is just guess based on a heuristic if we're below a certain threshold of traffic, of network traffic, that, hey, this workload might be dead. And if you just get rid of it, you can save some money. So that's the last piece of savings that I'll mention. There's plenty more here we could talk about, I'm sure, all day. But there's that. Last thing, I think we should do questions now. Any more questions if there are any, but we can be purchased through the AWS Marketplace if you want our paid editions, which does smooth the path for some of our AWS users.
I think, authentication integrations, enterprise support for SAML is supported in enterprise. So I don't know what AWS Cognito uses or if they have SAML support, but that's what we've got today. Would love to hear more about like specific enterprise needs there. We have more than one cluster in different, absolutely. Like you can run CubeCost anywhere it runs, and as long as they all thread together to the same, so whatever you're using to back your multi-cluster setup, many people use Thanos, so it's just an S3 bucket that backs all that data. What kind of alerts do we have, and what do we integrate with? Sorry, this is the lightning round. So today, integrations on the output, Slack and email. Email does have to go through like a send. Both of these obviously go through a third party, so you'll have to we don't integrate with like an SMTP server that you bring, but Slack, if you're running your own Slack, I think you can set those up. It's the Slack webhook format, basically, is what we integrate with there. What kind of alerts? Those are like, we do, I'm going to try my best here, but there's more. What I'll do is just share more documentation about the kind of.
Yeah, off the top of my head, there's like, you can have like regular cost reporting, like on a daily, weekly basis. You can have, if you exceed a cost threshold, if you exceed an efficiency threshold. I think there's a couple more.
I'll just paste it, or how do
Yeah, I can throw it in the chat too. So
okay, I'll just drop it.
over.
It's that.
CubeCost does include network costs. There's one extra like flag you have to flip, but we have basically a daemon set that gets deployed and keeps track of all the network traffic that's happening, and then connects that, if possible, to your billing report to sort of assign a cost to the network traffic.
And I know, again, lightning round, I know this is fast, it's all documented, but you don't need the daemon set. If you don't have the daemon set, but you do have a cloud integration, we'll still pull costs from AWS, but AWS will only break those down at the instance level. If you want to go down to the pod level, you've got to run the daemon set. So,
and that's egress and cross AZ or cross region traffic.
Yes, again, it's an estimate on the pod level reconciled with what AWS is saying, and then like split proportionally across the pods on the node. It's again, there's a lot going on here with the math and the backfilling that I'd love to get more into, but it would be like an advanced session.
Yeah, and if you have more deeper questions, you can hit us up on Slack as well afterward.
Today, I don't think we have Kubernetes operator support. I know a number of teams have done this, like as third party with us. Like people are running this as operators. I think there may be one in the wild. We don't support one on our team, but I think it's definitely a good idea. Right now, it's just Helm install in a namespace, and it's a number of pods, and you're responsible for all the upgrades and things like that. But yeah,
cool. Well, I mean, I learned a lot. This has been great. Just understanding a lot more about, what you can do to get some of that detailed cost, how you can report that, how you can show that to other people and share it has been awesome. So thank you both so much for coming on the show. Again, if people want to reach out, what's the Slack for CubeCost? Is there
if you go to our website, cubecost.com, there are links to all of our social media and our community Slack, which you can hop in at any time.
Cool. Yeah, because I'm sure there's plenty of other questions there. But yeah, if anyone wants to run it, reach out. It's a really cool tool. There's so much free stuff you can do in the community edition. If you have a personal, Kubernetes cluster, you're running your own stuff, just to be able to see some of those detailed analysis of like, oh, maybe I should optimize this other thing. And those reports are just great just to keep visibility, because if you're not tracking it, it didn't happen. So
yeah, cool.
So thanks everyone for coming. Thanks for all the questions. I do have another show with Loft in virtual clusters tomorrow, so I'm excited for that one as well. Go ahead and subscribe on Twitch or on YouTube, and we'll see everyone later. Bye.
Cool.
Bye, everyone.